Hello everyone, today we are going to implement this turret in Unreal Engine 5 using C++. So we will be implementing everything from the scratch. We will import this model and then create the turret class within C++ and all, define all the components we need and define this behavior. Everything will be C++, and let's see how to do that today. And this episode is sponsored by these generous patrons. Thank you very much for your support. Right, so here is my Unreal Engine 5 installation. Let me launch it. So actually when I run the launch the Unreal Engine 5, it doesn't give me the new project window. It directly open the previous project that I was working on. So let me go to file and create a new project and select from start. So actually I don't need anything for the moment, so let's start with a blank project. So UE5 C++ turret. This is the project name I'm going to use, and I'll choose C++. So actually even if I use select blueprint here, it wouldn't be a problem because this is a blank project. Let's create. Alright, this is the project. I don't need the sequencer. And I have project files out of date notification in my left monitor, so I just pressed updates and I got the notification successfully updated. Right now, so as I said, I'm going to create a turret here. When I play, let me play and see what happens. Well, nothing. Cool. So first, yeah, it's just a game mode. Let me import my turret model because that's the one I'm going to use. It's a skeletal mesh import. Right, this is the turret mesh I got. This is some free model that I found in the internet. Feel free to use anything you like. Okay, let me scale this up. And I don't need the mesh right now. Now let's get started with our class. First I'll create a C++ class, but actually it in Unreal 4 it was here. Create C++ class. I wonder where it is. New C++ class. Okay, so actually this is going to be an actor. Turret is going to be an actor, so I'll select the actor as the base class, parent class. Next I'll call it turret. The name is already used by another class. Maybe is that I don't have any other classes here. Is it this? I'm not sure. Let's call CPP turret. Okay, CPP turret. Create class. And Visual Studio opened up in here. So I have already installed on Visual Studio 2019 Community Edition. thing. So if you haven't, you have to install that. I'm not going to cover that step here. So right, so now here is our turret class. This is the turret cpp turret header file, and this is the cpp turret C++ file, the implementation. Right, so let's go to the header file and let's start defining the components we need for our turret class. And first I would need a root component, and then I would need a skeletal mesh component that hold the turret skeletal mesh, and then I would need a beam, and yeah, basically that's all I need for now. Right, so let's start defining the components. Here I'll open a private section, UPROPERTY visible anywhere. So here I'm going to define USceneComponent pointer root, and I get some errors, and also I didn't get any suggestions. I think that's because IntelliSense is still running. So this UPROPERTY. So this is the macro that says into the Unreal Engine reflection system that this component is going to be visible in everywhere. That means in C++ classes that use this class reference, and also in blueprints as well. So the next thing we need is UPROPERTY I'll define the properties file properties specifier later, and this is going to be a USkeletalMeshComponent pointer turret mesh. So this I don't need to edit this when I place one of them in the level. I only need to edit them when only in the, let's say, the class blueprint. So edit defaults only. Right, so if you don't know about these property specifiers, you can find the documentation here. You have all the details relevant to that. All the properties here, you can look into them. Right, now I have defined the variables. Now let's initialize them in our cpp turret class in the constructor. This is the constructor. So let's add a scene component object into the into this root reference we define. We can do it like this: root equals create default sub object in the type of USceneComponent, and we can define a name here. And whenever you give some string, you have to use this text macro to make sure that this works on any regardless of the text encoding scheme the underlying machine uses or underlying operating system uses. So root and this has to be the root component. So let's set this as set root component root. I'm gonna set this object as the root component, and then Similarly, I'll create a sub object for the turret mesh as well. Turret mesh equals create default sub object. Now this time this turret mesh is a skeletal mesh component, so use skeletal mesh component, name is text, turret mesh. Right, and this should come under root, so we can go turret mesh, set up attachment root. So using this we can attach our turret mesh into the root scene component. So now let's go here and compile. And where is compile button? Here. Hard to find if you don't know. Right, let's see if we get any errors. Okay, compilation complete. Now here we can see our CPP turret. Using this, let's create a blueprint class. The reason I am creating a blueprint class is actually it is possible to set the actual skeletal mesh reference through the C++ code as well, but that's really it's like hard coding the reference through the C++ class, which is not really good. So blueprint is really good when it comes to setting up visual stuff. So let's create a blueprint class based on CPP turret. This is really easy for us to manage our classes as well when we have a blueprint version. Oh, can't we create a new folder here? No, we can't. So let me create a new folder, blueprints. Right, now create blueprint class based on CPP turret. I'll call it BP turret. Let's add a underscore. Right, now you can already see the root component and the turret mesh here. So here now we can assign the turret mesh skeletal mesh like this, and now let's place one of these here. Cool. So we have our blueprint instance of a blueprint version of the turret mesh that is based on the C++ class we just defined. And what I said about this property specifiers, edit defaults only, this is visible anywhere, so we can actually see the root component everywhere, blueprint or C++, and here right, that's not important. So the next thing we need is a laser beam. So actually I'm not going to create any particle beam here. I'm just going to put a cube, a long small cube as the laser beam, and assign some red illuminating material, and I'm going to attach it to a socket. Where should I attach it? Maybe right under here. I'll add a socket. Let's call it beam socket. Alright, now let's add the laser beam. For that also we need a static mesh component. UPROPERTY visible anywhere, static mesh component pointer beam. Okay, same as before, we can create a default sub object for that as well. Beam equals create default. I don't get the suggestions because these background tasks are running, and actually usually Studio is a bit slow in my PC, so anyway we have to deal with that. We create default sub object, use static mesh component, text, let's call it. If you want to put something like, you can put something like laser beam, and this must be attached to the beam socket we just defined here. So let's attach this beam setup attachment. So here we can give a socket name as well. So if I don't give a socket name, the default value none will be applied. That means it will just attach it to the root of the whatever the object that we are trying to attach, whatever the parent that we are trying to attach. So here as the parent I'll give torrent mesh, and as the socket name, remember you have to use text macro whenever you are going to give a string. Some beam socket. Okay. All right. Let's compile. Got an error. Let's see what it is. N is missing. Sorry about that. Okay, now we have the beam here. We don't have any meshes to assign. Let's make visible the engine content and assign. Now I can assign a cube. Okay, this is too large. Still too large. Z and Y could be 0.0, 0. Okay, that size is good. And X, this has to be long. So 100. Okay, and this should start, beam should start from here. So let's have an offset of -50. No, instead of 100, let's try it at 5. Okay, this works, right? And also I noticed that the forward is here, but the mesh is facing that way. So I think actually we can rotate the mesh here. So these things you don't have to do these changes in C++. You can just easily do those things within the blueprint class. So that's why we need to use blueprint and C++ together. That makes things more convenient. Right, let's quickly create a material for the beam laser. This could be an unlit material. To emissive color. Right, 100. Apply and close. As the laser material, I'll use laser. Cool. Okay, that's good enough. The reason that this laser beam is so that we can see where is this turret is looking at the moment. Actually, I already also have the textures for this turret as well, but that's not important here. I just want to work on the C++ part first. Right, now we need to rotate this head of the turret. Oh wait, this part. Oh no, this part. No, actually horizontal plane this and the vertical plane is this. So we need to create an animation blueprint, and the animation blueprint is something you can do with blueprints. You don't really need to use C++ for that because it doesn't really make sense, because blueprints are more visual. Very easy to use blueprints for this type of stuff. BPA, or let's just say BP turret. Okay, so in order to rotate these bones, we have to do transform modify bone. We can use transform modify bone node. So first let's get mesh space reference bus and transform modify bone. So as I said, first we need to modify this laser gun tower bone for the horizontal plane rotation. So select as the detail, right here, bone to modify laser gun tower 001. And we need to we don't need to do any translation, only rotation. So rotation could be in this could be replace existing, yeah. and I think component space would work. So let's promote this to a, actually we only need, as I said, we only need to change the rotation in the horizontal plane. So let's try adding 30 and see if this works. Yeah, it works. See, so we only need to modify the Z component, but I'll add a variable in the type of rotator. Let's call it look at rotation. Get it, split it. We only need to modify yo, so connect yo. I think since we have 180 turn here, yo here, we might have to add 180 to make it correct. We can test and see. Right, so this is horizontal plane, and for the vertical plane we need another transform modify bone. And this time we have to modify the circle 002 bone. Right, so here we need to change pitch. Let's try 30. Let's look down. Minus 30. It looks up. Right, so that means we have to multiply this with the -1 before plugging it here. I remember these things because I already worked on the blueprint version of this same tutorial some time ago in multiplayer series. Right, now we need a way to update this rotator from our C++ class in order to dynamically rotate this turret. So for that, let's set up an interface so that through the interface I will be able to change this look at rotation. So let's go back to our content browser and C++ class turret, add new C++ class. I'll select this time Unreal Interface, a UObject interface class to be implemented by other UObject based classes. I'll name it turret anim interface create class. Okay, so here is the turret interface C++. I don't think I would need any implementations. Right, so here I'll add a U function that can be implemented and called from blueprints and as well as from C++. So U function blueprint callable, so that means we can call it from blueprints. And blueprint native event, so we can implement this in blueprints. We can define a category as well. This is optional. Sorry, turret animation. So the function name void update look at rotation. As the parameter, we have to give an f rotator rotation. So this is a interface, so obviously we don't need to implement it in the C++ class. Here we don't need to implement this, but we can call this from our C++ turret when we have a way to, when we set up a way to change the look at direction dynamically, look at rotation dynamically. Right, now let's implement this interface in our animation blueprint. Let me compile first. Okay, ABP turret, class settings, add interface, turret anim interface. Right, now we got that function we just defined here. So let's define it. Let's implement it here. Actually, I don't think I directly need to set this. I can set this with the R interp, so we can smoothly change the look at rotation. So to do that, get the look at rotation, R interp to current is this, target is whatever the rotation we give through the function, delta time, is 12 delta seconds, interp speed, let's try 0.1. Right, okay, that's all for the blueprint part. Now we need to think of a way to change the turret look at direction in the runtime. So the way we did our blueprint version is we defined two scene components that user can change the locations, and turret will look at one of them and then it will look at the other. So it will like keep kind of looking at both of them one after the other. So let's do the same thing here. It's like a sweep in an area, more like a searchlight. So let's call them targets. So I'll add UPROPERTY. So I'm not going to define any of the property specifiers here. I just mark them as a UPROPERTY, and USceneComponent target 1. Now even if I don't add a specifier, adding a UPROPERTY is important because this is identified by the Unreal Engine internal reflection system. This whatever the variable we are defining here, so that that will support internal garbage collection and all those things that's happening inside the engine. Target 1, target 2. Right, now let's create the sub objects. Target 1 equals create default sub object using component target one and target one set up attachment. We just attach this to root. It doesn't have to be a child of turret mesh, and we can do the same thing for the target 2 as well. By the way, you can do a selection of multiple lines and type if you keep Alt pressed. Let's compile. Oh, I forgot to save the scene. Until it compiles, let me save the scene. Turret demo. And let's set this as the default map. Next time I start, I will have the turret demo there. Right, now in the BP turret we have target 1 and target 2. Why none of these details available here? They're not also visible here as well. Maybe it's a problem with hot reload. Shall I compile again? But without compiling there is no way to appear this detail. So let me restart. Right, again restart Unreal 5. Okay. Still no. Sorry. I forgot to add the property specifier here. Visible everywhere. Please. Cool. Now we can see it. Okay. Alright, so now what I'm going to do is let's see, let's set the target 1 over here. So 1000 target 2 okay, so this beam will turn to this side and to this side and to this side in a cycle. So that's basically what I am going to do. So I'm gonna add another scene component and the beam will always follow that scene component, and when I want to change the direction of the beam, what I'm gonna do is I'm gonna change that that the component which the beam follows, I'm going to change its location, so beam will also follow it. So let's go to C++. Add another scene component. I'll call it follow target, and I'll add a function, a U function. I don't need to call this from blueprints, so no need to add blueprint callable property specifier. Wait, update target, or shall we call it look at target? That's better. And let's create the definition of this function here. In the C++ class. Right, actually it came before the constructor, but I don't like it. Let's put it below. pp current update look at target. Okay, so now what I'm gonna do is I'm gonna calculate the look at rotation from the beam socket towards the follow target, and use that calculated rotation and update it in the animation blueprint set look at rotation value. Using that interface we created a while ago. So to find look at rotation we need two things: the starting point and the end point. So f vector start equals, so turret mesh get socket location. What's the socket location? Beam socket. It should be beam socket as I remember. Yeah, beam socket. And the f vector end equals follow target with component location. Okay. Oh wait, we actually forgot to compile and see the follow target in blueprint. Alright. Where is the follow target? I forgot to initialize that here. Follow target. That's why I couldn't see that here. Right, now it is. Okay, so what I'm gonna do is I'm gonna change the location of the follow target, and beam will keep following that target. That means beam will keep looking at that target. That's what I'm trying to do here. Okay, so go back here, vector. So now we need to find look at rotation from the starting point to end point. So find look at rotation is defined in check UP4 C++ at rotation in USkeletalMeshComponents math library and include this. Copy this. Copy this Kismet math library, otherwise you can't use this function. And this is the function. It returns an f rotated, and you have to give to starting location and end location f vectors. Right. We need to save the rotation into f rotator. Look at rotation. USkeletalMeshComponents math library. Find look at rotation. Start is start, end is end. Right. Now we need to update this calculated look at rotation into our animation blueprint. Oh, I haven't assigned the animation blueprint yet. VP turret. So basically we need to call this function, and to do that actually we are going to call it through the interface we defined. In C++ we can just call it as a message, but this is the way in blueprints we can just drag a line and call it as a message, but this is the way in C++ that we do this. So we need to call this update look at rotation function on the anim instance of the turret mesh. So first we need to check turret mesh anim instance get anim instance, and check if that implements the turret anim interface. Turret anim interface. So implements. So in order to use the turret anim interface, we have to include the header file. Include turret anim interface.h. Now we can use the type turret anim interface. So this will return true if we have implemented turret anim interface in whatever the animation class we have used to drive the animations of the turret mesh. Then again we can actually execute that function now. So for that, I turret anim interface and execute update look at rotation. So here as the parameter we have to give the object that we are trying to execute this function and the parameter. So turret mesh get anim instance, and the rotation is look at rotation. Okay, and we need to call this update look at target in the tick. So here, update look at target. Right, let's compile now. And let's say let's simulate. Right, now you see this beam is turning. That's because if I select, the follow target is over there. Something is wrong in our calculation. Oh wait, this, let's try world space, and this one should be parent bonus space. Yeah, now that's correct. Actually, maybe by accident there is an offset in the location of the root component. I'm not sure why that happened. Right now let's when I try to play, project crashed. Line 53, CPP turret line 53, there is an error, access violation. Let me restart. Right, for some reason follow target is not available in this BP turret instance. So let me delete that and add again. Still not there, but here it is there. Follow target is there. So what could be the problem? Because I have set it to visible anywhere for both, for the follow target and target 1, target 2, all are same. And yeah, I do get it here as well, but for some reason I don't have it here. Let me recompile. Do I have any typo of this access specifiers? And the detail is also not there. Is that a save problem? But there is no way of appearing this two and not appear the follow target. Honestly, I'm not sure why. So yeah, we do have this. So let me copy and paste, make target 3. Just to see if that works. Right, target 3 appeared here. Okay, then since I can't find what's wrong here, let me copy the name and rename it. Follow target. Looks like the problem is with the name. Okay, right. Let me undo this. Let me rename this as beam target. And let me comment these locations where I have used follow target for now. Right, I got the name here, beam target. And it's available here as well. Cool. Now let me uncomment this part, and instead of follow target, let's use beam target. I don't know why it's what's wrong with that name, follow target. So let's try compiling now. Okay, and play. Beam target is here. If I move it here, you can see the beam is adjusting its, but it's too slow. It's aligning it with the beam target tag is, but it's too slow. Right, actually I forgot to save those changes I did for the space. Replace existing world space and replace existing parent bound space. And here let me increase this interpolation speed a bit, and in the BP turret I'll put the beam target in front of the turret. And actually previously I told you something wrong. This route has some offset. Actually this is right, this is the world space change, I mean world space location. Actually I kind of thought it's like there is some local offset. That's wrong, this is okay. So now if I play, you can see, right, turret is looking at the beam target. So if I change the location of beam target, you can see turret is turning to that. See, slowly turning to that. Okay, so now what I have to do is change in the location of this beam target in a timer in between this target 1 and target 2. So the turret will look this side and to this side and to this side, so it will happen continuously, right? So to do that we have to use a timer. And how do we use a timer? F8 C++ set timer. Git time manager, set timer, member timer handler. This is the function we need to use, and we need a member timer handler, a timer handler, and a function, a repeating function. So let's define. I'll add another u function. So we need to change the target. U function void change beam target, and we need to keep track of like the iteration that this timer is being called. So for that I'll add a UPROPERTY. Actually it's just a simple int, so maybe it's not necessary to define it as a UPROPERTY. Timer count, this should be an integer. Starts with 0. Also we need a timer handler. In order to use timer handlers we need to use, what's the header file? Time handler. Where is it defined? Include. Okay, this one. Agent types. Timer handler, sorry, not timer handler, F timer handler. Timer handler, timer handler. Right, now let's implement this function. So what I'm gonna do is first increment timer count, and then if timer count modulus division 2, if this is equals 0, that means we are in an even iteration. So I'm gonna set follow target location or beam target location as the target 1, else target 2. So beam target set component location target 1 hit component location. Why can't I access it? What's wrong? Sorry. Set word location, that's the function. Else same thing but with target 2. Right, now we need to start the timer. Let's do that in the begin play. How to do that? Using the function I showed you guys. Get word time manager, set timer. This is the function we have to use. Get word timer manager, set timer, and timer handle. We already defined it, and we are going to use this overload. Timer delegate is this class, and the function is not U class, this delegate, this overload. Function is, and so we need to give an address of the function, cpp turret change beam target, and we need to call this in every, let's say, 5 seconds. Initial delay 5 seconds, should be a float value, and also this should be looping, so true, it should loop. Initial delay, let's just say 1 second. Is that correct? Okay, I think that's it. Shall we compile? Okay, let's test. Right, so it is working. Actually, since we have used an R-interp, we don't have a constant speed when it is changing the rotation. Initially it is a bit fast, then it's a bit slower, but that's fine. And even in the runtime we can change the targets. So if I move it up, beam covers a wider area. Right, so I'm gonna stop this episode right here, and thanks for watching. Hope you learned something. So I will, in a future episode, I will work on like shooting, how to detect a target and how to shoot that target when the target is detected with the laser beam. I will do that in future episode. And if you like to support my work, you can get the membership of the Patreon Club. Link could be in the description below. And if you like, see you in another episode. Goodbye.